No, no. I need to give her time to get set up. So it may seem to you like I was wasting time, but actually I was giving Leilani time to set up. But also I was wasting time because I'm really into it. I can't. What's that?
Strategic time.
That's right, strategic waste of time. That's what I'm all about. Yay, Omar's here. Yes, sure. Yeah, now that Omar's here, you can go use the restroom because I have to keep a steady state system of students. Once he walks in, you can walk out. Okay. So sorry. Here comes another example. Okay. I want to do, remember the function we were using yesterday? F of x equals the square root of x plus 1. Okay. And I wanted to approximate the area under this. 1, 2, 3, 4. From 0 to 4. Right? And so my function looks like this. Okay, and I want to estimate the area. I already gave you my little intro that talked about why we care about the area. It's as if I graph a rate versus time, then the area ends up being the total quantity. I already hopefully established the usefulness of getting the area. And so I asked you guys, well, let's go ahead and add rectangles. How many rectangles do you want to add, hoping you would choose some number like 4 or 8 or 16 or 12 or something. But instead, you chose 2.
What? Who chose 2?
Yeah, that would be Andrew. Thank you. Okay, so Jawad, let's see what this is. Ooh, I guess that's worth it. If it was like the Chapman College, I wouldn't let you go. Oh, Kylie's not here.
What is it for?
But it's actually to a good college. Okay. Well, now I'm going to have you do it for a different number of rectangles. We're going to do it for 8. Yeah, we're going to do it for a lot more rectangles. And then I want to compare those answers to the real answer. And today I'm actually going to teach you how to find the real answer with your calculator. Okay, so and then tomorrow I'm going to give you just this infinity of theory about why it all works, why it happens. We'll learn about Riemann sums and we'll learn about Leibniz notation. But today I just want to introduce to you, hey, this is the way you do it on your calculator. Okay, so anyway, I'm going to make 8 rectangles. So I'd like everyone to please draw this and make 8 rectangles. That is 8 partitions. You don't know how big the rectangles are. You don't know what the height of the rectangles are yet. So all you can do is this. You can just go, okay, I'll make 8 partitions, but I don't know how high each rectangle is going to be yet. Okay? Because that's what, oh, look who's here. Speak of the devil. I'll make your chain. Oh, Mrs. Brubaker. Why were you guys at Mrs. Brubaker's? Why were you at Mrs. Brubaker's? Oh, good enough. She's a nice person. I like Mrs. Brubaker. Yeah, she's really, really nice. We had a previous department chairman named Keith Jones, and he ended up getting this horrible, horrible disease called valley fever that got combined with another fungal infection of the lungs, and it almost killed him, and it made him have to retire. So he stopped being the department chairman, and Mrs. Brubaker took his place, and she was just so nice. She was always visiting him and telling us how he was doing, and she just really showed a lot during Keith Jones's illness. So that's what I think of when I see Mrs. Brubaker. I think, wow, she was so awesome during Mr. Jones's illness. So anyway, yeah, she's a great person. Okay, so I've got my 8 rectangles, right? But we don't know what height they're going to have. We know we're going to be adding them up, but we don't know what height they're going to have. So let me ask you guys, which would you like to do, LRAM, RRAM, or MRAM?
MRAM.
How many people want to go LRAM? How many people are going to RRAM? Okay, how many people want to go MRAM? God, you guys just love MRAM. Alrighty, okay, let's do MRAM. Then you guys, okay, like for each partition, the height of each rectangle will be the y-coordinate of the midpoint of each partition. So each rectangle, I'm going to be going, okay, I want the y coordinate of each of these midpoints of the partitions, each of these little pink guys. So, you know, this is 0.5 and 1 point, wait, my bad. Yeah, this is 0.25 and 0.75 and 1. Really, you want to do that? God, I would have gone with one of the easier ones. You guys keep messing up my lessons because I expect you to go for one of the easier ones and you went for the harder one. Okay, so looking at this guy, alrighty, his height is going to be, you know, f of 0.25. That's the height of the first rectangle. And the height of the second rectangle is going to be f of 0.75. And the height of the next rectangle is f of 1.25, etc. The height of each rectangle is going to be, and I'm having trouble drawing a horizontal line. Okay, here we go. But the height of each rectangle is going to be the y-coordinate of the midpoint, for some crazy reason, of each partition. Okay, so let's go ahead and do this thing. And I just want you to notice that the area ends up being, you know, the delta x times f of 0.25 plus delta x times f of 0.75, etc., right? I want you to see that each one of these rectangles has the same delta x, the same width. We call delta x the width of each partition. And you tell me, what is my delta x here?
1/2?
Yeah, 1/2. And I want to remind you, the quick way to get that, if you're ever wondering, is it's always going to be b minus a over n, where this guy is a, this guy 4 is b, and n is the number of partitions. So in this case, it ends up being 4 minus 0 over 8, which is 1/2. But you usually are going to be able to just draw the thing and look visually what the width of each partition is. Well, do you mind if I factor out the delta x's? So I got delta x times f of 0.25 plus f of 0.75 plus f of 1.25 plus dot, 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 all the way to f of 3.75. Okay, well, guess what? It's time to do it. Now, does anyone know how to use their table on their calculator, where you can designate what delta x is and put in a function and it finds all the y's for you? Well, if you know how to do it, do that. If you don't, then just do it the hard way. Frankly, I don't know if I know how to do that. I didn't expect you guys to choose something this hard.
That's not good.
Here, just a second. What is the second? Oops. There's the table. So table set. So table starts 0, delta table 0.25, independent auto ask what? And so here. So what if I put square root of x plus 1? Okay. Okay. Is that looking good? Okay.
That's not what it does.
So each one of those guys is f of like 0, f of 0.25. And I can see f of 0.25 works because radical 0.25 is 1/2 and 1 plus 1/2 is 1.5. So there it is. So anyway, those of you who have a TI-83 or a TI-84, I wouldn't know how to do this on an N-Spire. I'd have to look at the instructions. But you do table set and have your table start be 0 and your delta table be 0.25 and just have it be auto. So the defaults are always just, you know, what they are. And then you put it in, put the function as y1, and then your table ends up being that stuff. So So my area is gonna be 1/2 times 1 plus 1.5 plus 1.707 plus 1.866 plus 2 plus 2.118 plus 2.2247 plus, is there any more? I thought I was only supposed to have 8. Oh wait, I'm going by increments of, oh, what a bummer, my stupid table. Okay, I understand what went wrong. Okay, all right, I'm so stupid. Mr. Shane is stupid. See, that's what happens when you don't know what you're doing. Table start 0.25, delta table 0.5. Okay, oops, stop that. Okay, there we go. That's what I want, right? That's what I want. 0.25, 0.75, 1.25, etc. Oh, I'll let him there. Right, f of 0.25, f of 0.75, etc. If you would have done it the long way, you'd probably be done by now. But look how much easier the table is. Is that it? No, I get one more. .937. Okay, boy, this is going to be on YouTube. This is going to suck. It's like, looks like Mr. Shane is just struggling. Alrighty, so we got 0.5. And I wonder if there's some easy way for me to actually make a list where I can add the things of the list, but I'm not going to go to the trouble. You can tell on an exam, you're not going to get many partitions. In fact, quite often, on the AP exam, if they give you one of these, it'll be no more than 3 partitions, because they don't want you to spend all day on this. Okay, so I get an area of 9.3525. How many people got that? Okay, great. And I just want to make sure you're aware, I could do LRAM or RRAM, and I hope you remember from yesterday, LRAM is going to give me an area, in this case, that's too small, and RRAM is going to give me an area that's too big, you know? I want to remind you that if we had done LRAM, then my area would have been 1/2 times. If I'm doing LRAM, then I hope you see the first y value would have been f of 0, because the height of the first rectangle would have been the y coordinate of the leftmost point. So it would be f of 0 plus f of 0.5 plus f of 1 plus ... all the way to f of 3.5. And then that's it. You would be done. That's what you would get with LRAM, where you got every single rectangle, the height of each rectangle is the y coordinate of the leftmost point. Whereas RRAM, your area would have been 1/2 times the first rectangle, its height would have been f of 0.5, and then f of 1 all the way to f of a 4. And this guy would have been too small, and this guy would have been too big. By the way, what is it about this graph that lets me know that LRAM is going to be too small and RRAM is going to be too big? What about this graph makes it so that LRAM is too small and RRAM is too big? Thank you. Who said that? Was that Chris? Chris?
No, it's not.
No, what? Wait, what? Who's Zach? So bad. You guys are just ventriloquists. Yeah, thank you, Zach. It's because this guy's increasing. I'm just repeating what Zach said. And so if this guy was decreasing, then how would those guys be? Yeah, it'd be the opposite. Okay, so now there's a way you can actually get this area, and I'm going to show you that now on your graphing calculator. If you press math and then 9. And what's going to happen is you're going to get FNINT, which is a numerical integral. And then what you do is you put in the function, which in this case would be radical x plus 1, comma, then you put in what you're integrating with respect to, which is just x, because that's what you're integrating with respect to, is x. And then you would put in the lower bound, the a, which in this case is 0, and then the b, which in this case is 4. And it'll actually get you the exact area. So if you want, go ahead and do that now. Just press math 9, and you get your function integral. And then you can put radical x plus 1, which is the function, and then a comma, and then x, which is what you're integrating with respect to, and then the comma, and then what that is later. Then the lower bound, comma, then the upper bound, and parentheses. And now it's getting it. And you see that the real value ends up being pretty much 9 1/3. So using 8 rectangles to get the area, we actually got a reasonably good estimate, didn't we? I mean, it was good within 2 parts out of, essentially 2 parts out of 1,000. You know, it's good within 0.2%. So this method of estimating areas using rectangles can be a powerful method. Now, what if I wanted to be even more accurate than off by, being off by about 0.2%? What could I have done to make it a better estimate? Yeah, thank you, Omar. Use more rectangles. If I use 16 rectangles instead of 8, then it'd be an even better estimate. And ideally, to get the exact answer, how many rectangles do you suppose I'm going to use?
An infinite amount?
Yeah, an infinite amount, absolutely, Leilani. And that's what we're going to end up doing. We're going to end up using an infinite amount of rectangles, and then finding out that using an infinite amount of rectangles, allows me to do that sort of thing. All right, but anyway, hey, that's it. That's LRAM, RRAM, and MRAM. I don't have anything more to tell you. You just get to do tonight's homework. Just want to let you know, do not follow the book, because the book is going to have you choose 1,000,000 rectangles. And I don't want you to waste your life. So I want you to be doing, n = 3 for number 5, n = 4 for number 7, and then n = 5. This is a data table problem, but I just want you to do n = 5, and I want you to do MRAM. These guys, I want you to do all of it, LRAM, MRAM, and RRAM. By the way, what is it about MRAM that makes it a more accurate estimate than RRAM or LRAM?
You're taking the average of the two.
Okay, true. You're kind of taking the average of two. It's not really truly the average of the two, but you're right, it's in between the two. What else is it? Like here, if this is my function, okay, and let's say I only have 2 rectangles, but I end up letting the height of each rectangle be the y-coordinate of the midpoint of the partition. Someone described for me in their words, what is it about MRAM that makes it a better approximation than RRAM or LRAM? Yeah, Andrew.
Because when you take the middle, the space that there technically isn't rectangle.
Yes.
There, that is basically the flip of where you're not getting the rectangle.
Yeah. Good.
It fills it in.
Yeah, you end up overshooting this part and undershooting that part, and so they seem to balance each other out somewhat.
Roughly.
They don't balance each other out completely, as you can see there. You're still off by 0.2%. But yeah, MRAM is a more accurate way to go. Okay. But, LRAM and RRAM are usually easier to do, and sometimes you don't need that much accuracy. You rather just go with ease. But on the AP exam, they do want you to be able to make a distinction between LRAM, RRAM, and MRAM. So if they ask for LRAM, don't give them RRAM or you'll get the question wrong. Well, hey, I've got nothing more to say about this. I'm going to start doing data tables. So does anyone have any questions or issues on this? Okay, then here's the beautiful thing about approximating areas with rectangles. Oops.
You know how to do it? Do you want to know how to do it?
suppose you're driving a car, okay? And you want to see how your car performs, okay? So you jam on the accelerator and your car goes faster and faster and faster. And you would like to, get a true idea of what the speeds of your car is every moment, and so what distance your car is going every moment. The problem is, while you're doing this, you're driving on baseline and there's a ton of traffic, so you really have to keep your eyes on the road. You can't be writing down, what your speed is every fraction of a second. So you decide, well, I think I can, look up every, 5 seconds maybe. I can look up every 5 seconds and write down the speed. Okay? And from doing that, maybe that's enough for me to get a good sense of how my car is performing as I zoom down baseline, juking through all these cars and stuff. Okay? So you see what we're doing right now. You don't have a formula. I don't have a function telling me what my speed is with respect to time. In fact, I'm not even getting a graph. All I'm getting is a bunch of discrete points 5 seconds apart. And yet, with those discrete points, I can still get a good idea of what my car is doing and what distance my car is going. So let me show you what happened. So, and I'm gonna measure it in meters per second, just because I'm a physics teacher.
Cool.
Even though my thing is going to say either miles per hour or kilometers per hour, but I don't want to convert. Okay, I'll show you problems later where you do convert, but right now it's not. So here's my time. Okay, and here's my speed. Alrighty. One, two, three, 4, 5, 6, 8, 9, 10. Okay. Okay, great. So I can go 1, 2. Yeah, beautiful. Okay, and so 1, 5, 10, 15, 20, 25, 30, 35, 40. 45, wait, what? Oh, yeah, that makes sense. And then my speed, let's say I start from rest, and now, and this is speed is in meters per second, and this time is in seconds, and so maybe this is 6, and then 12, and then 20, and then 27, and then 31, and then 29, and then 24, and then 15, and then 6. Because I guess there was some kids in the crosswalks and I had to slow down. Okay, so go ahead and write that stuff down. And here's my question to you. Estimate the distance I went from time equal 0 to time equal 45 seconds. What distance did I go? Well, tell me, how are you going to make that estimate? What should you do first?
Multiply.
No, don't do that stuff.
Find slope.
Say that again.
Make a graph.
Yeah, make a graph. Essentially, I'm advocating that you turn this problem into this, because you guys are already experts at this, right? Turn that problem into this. So please graph this now. This is time in seconds. This is velocity in meters per second. This is my exact velocity. I gotta go to 35, don't I? Yay.
Could you make your time, make your increments of 5 as your delta x, and then multiply it by your speed?
That's what we're gonna end up doing. Yeah.
What's it a multiply?
But if you're trying to weasel your way out of making a graph, it won't work. Although, yeah, I mean, Abigail, you're right. There will come a time when you can do this without a graph. But since I'm just teaching it to you now, I need you to be able to do this as a graph. 5, 6, 10, 12, 15, 20, 27, 25, 31, 30, 29, 25, 24, 40, 15, 45, 6. Okay. And of course, your graph doesn't have to be that accurate because we're just using it as a tool to be able to do the problem. You know, I'm not actually going to be measuring stuff. Tell me, should I connect these dots with a solid line?
Connect the dots.
We would like to connect the dots, but why am I not allowed to connect the dots?
Because it's a plot, scatter plot.
Well, it's discrete points.
Yeah.
Just because at 0 seconds I'm going 0 and 5 seconds I'm going 6, you have no idea what I was going between 0 and 5.
Yeah.
Right? No idea in the universe. I could have been going 100 million miles an hour at 2.5 seconds, then I slowed down to 6 meters per second right there. I mean, who knows, right? But to aid your understanding, if you want, you can connect the dots. Just connect them with a dotted line. Just to remind yourself, hey, you know, I don't really know what was happening in between those times, you know? So, but if you like to have graphs that look like graphs, hey, be my guest, you know? And so now, here's my next question. How am I going to get the total distance I go? What am I going to have to do? What's that? Yeah, find the area. So how would you like to find the area? Yeah, let's add up a bunch of rectangles. How many rectangles you want to add up?
9.
Is it 9?
18.
Oh, it's 9 rectangles. Huh. Oh, I should have gone one more then. 9? I thought I counted 10. Oh, but I guess it's just 9 rectangles. Huh. Well, hey, just a second. Oh, hey, let me do one more. Hey, you guys, sorry. Let's go 52. Okay, great. Because of something I'm going to show you. Okay, so and how many rectangles did you want to count up instead of 9 now? 10. 10. Okay, great. And would you like to do LRAM, RRAM, or MRAM with your 10?
MRAM. Wait, LRAM.
Can we do MRAM with 10 rectangles? No? Because why can't I do MRAM with 10 rectangles? What am I going to use as the height of the midpoint?
Oh.
I don't know what it is,
Yeah.
right? So if you're going to use MRAM, how many rectangles are you going to have to use for MRAM?
Infinity.
What's that? Well, you tell me. Look at the drawing, because you can do
5.
MRAM, but you can't do it with 10 rectangles,
Yeah,
because you
sure.
don't know what the y-coordinate of the midpoint of each partition is. So what would you like the partition to be?
5.
Yeah. Wait, 5 what?
Rectangle.
You guys okay? If I use 5 rectangles with MRAM, then I do know what the y-coordinate of the midpoint of each partition is.
Yeah.
And so this type of problem is what I'm advocating for problem number 10. I don't want you to add up 10 rectangles. I want you to do MRAM with 5 rectangles. You see? So now I'm going to add up these rectangles. This guy plus this guy plus this guy plus this guy plus this guy. And I'm going to say, okay, the area of those 5 rectangles will be approximately the area under the graph. And actually, I'm going to get a pretty accurate estimate of how far I went. And I look at this, I'm only adding up 5 rectangles, so I'd like everyone to please do that now, and let's see what you get. And if there's anyone having difficulty, let me know, and I'll help you. So you're gonna do MRAM with 5 rectangles. Or 5 partitions. So N is 5. Okay, good luck. Do this and let's see what you guys get. So, what you guys get?
7.
What's that?
870.
How many people got 870 meters? Okay, a few of you. Is there anyone stuck on this? Anyone not getting like where I got those numbers from or anything? Also, notice how the units work out. 10 seconds per partition, 87 meters per second is the sum of all those speeds. So the seconds cancel and I get 870 meters, which is I would expect to get meters. I don't know. I was surprised more people didn't get it. And Abigail, do you see that when you get good at this, yeah, you don't even need the graph. You can just do it, you know, by looking at the chart. But I didn't want to do that for the first time. You know. By the way, what if you, let's see how far off LRAM is. Okay, I'd like everyone to please get the distance using LRAM and 10 rectangles. Let's see if it matters, how much it matters. I'd like everyone to please do that now. LRAM with 10 rectangles. So of course the first rectangle has no area whatsoever.
It's 0.
And you'll notice sometimes the LRAM undershoots the area, sometimes it overshoots the area. So it might work out okay. Am I okay? Did anyone get 850 meters? Yay, Angel. You did really?
Oh, you forgot
Just
to add
you
the
and me?
two.
What's that?
Oh wait, never mind.
Yeah, don't add that last one. 2 doesn't get added to it.
Yeah.
I'm only using the leftmost. So really, I'm the only one who got 850. Me and Angel, I mean, are the only ones who got 850.
I got 860.
Just do it in your head. Don't use a calculator. That takes too long. Just add it up in your head.
And the 860 is RRAM. You don't add the any.
Yeah, and remember, you don't add the 2. The 2 isn't involved because we're doing LRAM.
I accidentally did the 2. Okay.
That would have been a 2 disaster. An extra area disaster.
It only adds 10.
That's true. But you see, so you know, I just want you to see MRAM with 5 rectangles, LRAM with 10 rectangles. It's close. You know, remember, this is all just an estimate.
Which one's the right one?
Yeah, who knows what the right answer is? That's the beauty of it. Okay. Hey, so you learned how to do the adding rectangles for data tables as well. Any questions or issues on this? Because I don't know if I'm getting a lot of right answers. So, okay, now that we've had a couple minutes, how many people ended up getting 850? Okay, many of you, that's good. So, because I mean, I'm treating this like it's incredibly simple, because I guess it kind of is, but I'm hoping you guys are getting it, you know.
You can't pick.
All right.
It comes off. It's really
Let's see, and because I'm going to give you a heads up on number 19, and then I'm done. Any final questions or comments on any of this stuff? Yes?
If we were to do RRAM, would we ignore 0?
Yes. Yeah. Ikwok says, what if we did RRAM? Well, then you're ignoring the 0, and now you're including this guy. Absolutely. Yeah. And that would be okay. And so, in fact, you can even tell. I mean, let's say I did RRAM. What would I get? Since you're taking away the 0 and adding the 2, what would RRAM get you?
860.
Yeah, 860. Good for you. Yeah. And so that wouldn't be that bad either. I mean, 860, 870, 850, they're all close. All right, then there's one last thing I need to do is give you a heads up on number 19, and then we're done. And this wasn't a very efficient lesson, but it was fun. I mean,
Sure.
we're like a week and a half ahead of last year's class. It's kind of weird. I don't know how that happened.
Ahead of Morris is that?
No, last year's.
Yeah, I think Morrison is only like 1 day ahead of us, or 1 day behind us, right? Does anyone know Mr. Morrison students?
They're 2 days behind us.
Oh, they're 2 days behind us?
Mhm.
Yeah, I think what happened last year is I had to go to some stupid teacher conferences and other weird stuff happened where I missed class, and I don't know. But this year I'm not hardly missing any class. Okay, here's a heads up on number 19. Imagine you had this. Imagine you have a swimming pool, okay? And this swimming pool is 20 feet by 100 feet, let's say. It's 20 feet by 100 feet. But what's changing is the depth of the swimming pool. You see how that's going?
Oh, I hate those. I like to have
You guys see how the swimming pool, the depth is changing? Yeah, you're talking about when you do water polo?
I mean, I think it's kind of cool, and I have a love-hate relationship at the same time.
Oh, really? Like, don't you want to be on the side that's shallow so you can like stand and rest a little?
That, but it's also kind of cool when you go all the way down to the bottom, and you feel all the pressure in your ears. It's like kind of scary at the same time.
Oh.
You're a weirdo.
Like cheerful.
That's pretty interesting. Yeah. Oh.
No, 6 feet.
Well, anyway, so I want to get I want to get the total volume of this pool, okay? And so
At the very end.
I happen to know what the depths are. One,
That's like
1, 2,
120.
3, 4, 5, 6, 7, 8, 9, 10. I happen to know what all of these depths are. Let's say this depth is 3, and this depth is 3.2, and this depth is 3.7, and this depth is 4.1, etc., all the way to 8.0. All I'm doing is giving you a heads up. Tell me, how would I get the volume of this pool knowing what the depth is every 10 feet.
Fill it up and then make more water.
Wait, what's that? Layla? Okay, what's that? Oh, you said just pour a bunch of water in and measure the water? Don't do that. You know, and by the way, and I certainly don't want to make a million measurements, right? I don't want to stay all day in a pool with my tape measure measuring the depth at all points. So I'm just going to make 10 depth or 11 depth measurements.
Well, usually
But just with these 11 depth measurements, I can get a good estimate of what the volume of the pool is. Someone tell me, how am I going to do that? I know these 11 depth measurements. Yes, Carly?
You find the area of each of the intervals and then multiply it by 20.
Thank you very much. You guys okay? You can get the area of each one of these guys and then multiply by 20, right?
Ah.
The area of the base times the height for a prism. And so that's the way you're going to do number 19. You're going to get these areas and multiply by 20. And Carly, I couldn't have said it better myself. Thank you very much. Thank you for saving us from me having to like ask and wait and cajole and all that stuff. Yeah, so you're gonna add up all of these volumes. That's what you're doing. You're essentially getting this total area and multiplying by 20. Or if you prefer, you're getting each of these individual areas and multiplying each individual area by 20. However you want to think of it, it's all the same. All right, I'm done. Good luck, you guys.